All right, so in this section, we are going to talk about rational and radical equations. And you're going to have to pardon my handwriting. I sliced my finger open, so it's kind of awkward. All right, so a rational equation simply means a rational number is a number that can be written as a ratio of two integers. Okay, so a rational equation is just going to contain a whole bunch of fractions. All right, so we're going to just do something basic really quick. And so what happens if I've got 1/3 plus 2/7? Okay, if I'm going to add fractions or subtract fractions, I need a common denominator. And the common denominator allows the fractions to talk to one another. So your common denominator is going to be, a shortcut is to multiply your current denominators. Okay, so what I always do is I say I need a representative from every denominator. So I need a 3 and I need a 7, which means my common denominator is 21. That's the least common multiple between 3 and 7. It's the smallest number that both 3 and 7 divide into evenly. So how do I move from a 3 to a 21? I multiply by 7. So I can do anything I want to a fraction as long as I do it to the top and the bottom. And that means I'm really just truly multiplying by a 1. Okay? How am I going to move from this 7 to this 21? Well, I need to multiply by 3 on top and bottom. So if I multiply by 3 over 3, I'm really just multiplying by 1. So I'm not changing what it is, I'm changing what it looks like. So my numerator on this first one, 3 times 7 is 21, 1 times 7 is 7. Okay, 7 times 3 is 21, 2 times 3 is 6. And now my fractions can talk to each other because they have a common denominator. So now when I add, I get 13/21. Okay, radical equations are going to contain radicals. And so what we're going to want to do is kill off those radicals. So for instance, if I have the square root of x equals 4, I'm going to want to kill off that square root. So what's the opposite of square rooting something? It's squaring. So now when I square both sides of the equation, because I can do anything I want to an equation as long as I do it to both sides, the square root of something squared just pops up and I end up with 16. Okay, so the square root of 16 is 4. So you found the value to shove in for x to make that true. When we're dealing with radical equations, you're going to have to make sure to check your answer because some of these things go weird. And so you'll want to make sure and check your answers. When we're dealing with rational equations, that means we're going to have variables in our denominators. So we're going to restrict our domain first. In other words, I want to identify all the values of x that will make it undefined. Sorry. All right, so that being said, let me grab some of these examples and we'll just start talking through them. So what I have first of all is I'm just identifying or I'm restricting my domain. So my example is I have a 7 over 3x plus 2. And then I'm going to subtract 1 over x minus 3. And I want that thing to equal 0. So if that's the scenario I've got, what we talk about when we say restrict your domain, remember I can never divide by 0. So if I have this as a denominator with a variable in it, what I would like to do is make sure that I restrict my domain. So I'm going to say 3x plus 2 cannot equal 0. So take your denominator and say, boy, howdy, you better not be 0 because I cannot divide by 0. I'm not allowed to. And now we're going to solve this. So I'm going to subtract 2 from both sides. Oops, sorry. I'm going to subtract 2 from both sides. Okay. And then I'm going to divide both sides by 3. So what I find out is x had better not be a negative 2/3. If I solve this thing and I end up with an answer of negative 2/3, I can't use it because it'll mean I end up dividing by 0. So we're just restricting our domain. Okay, the next part is I got to look at this one too. So x minus 3 cannot equal 0, so I'm going to add 3 to both sides, so x also cannot be 3. There's an infinite number of things that x can be, but x had better not be negative 2/3, and x had better not be 3. Otherwise, when you substitute back in, your denominators will go to 0, and then you've blown up the world, and that's not good. Okay, so let's try another one, and we are going to go through and solve this thing. So when I go through and solve, I notice that I've got a rational equation. So a rational equation simply means I've got equations that are fractions, and I've got variables in the denominators, okay? So I've got 4 over x, and then I've got equals a negative 8 over x squared minus 2x. All right, so the first thing I want to do, and I'm so sorry, that's a 2. That would have screwed up the whole thing. All right, so x minus 2 is a denominator. X is a denominator. X squared minus 2x is a denominator. So the first thing I need to do is restrict my domain. And this is just kind of like wearing a seatbelt, okay? It's just making sure that if I run into an issue, I don't use any of the numbers that I find here. So I'm going to take this first denominator. I'm going to say x minus 2 had better not give me 0, so I'm going to add 2 to both sides. So if I go through this entire process and solve, and one of my answers is a 2, I cannot use it. Okay? Grab this denominator. X cannot be 0. Well, there you go. You're done. Okay? There's no solving to be done. On this one, I've got x squared minus 2x cannot equal 0. So far my domain is restricted. I cannot use 2. I cannot use 0. And now notice this magic right here. This is what we were doing in the last sections, is if I factor out that x, I end up with x times x minus 2 cannot be 0. So take this factor, you cannot be 0. Take this factor, you cannot be 0. And then solve this one by adding 2. Now look at what you just did. Okay, this factor or this denominator was an x minus 2. He's already over here. This denominator was an x. He's already over here. So your common denominator is x times x minus 2. I need an x, it's already in this one. I need an x minus 2, it's already in this one. So this has my common denominator. Now, what values do I need to restrict? I cannot use 0 and 2. Absolutely, positively, do not use 0 or 2. So now what are we going to do? We're going to go back to the original problem, and we're going to set this thing up with plenty of room to write. I've got x minus 2 plus 4 over x, and that's going to equal a negative 8 over x times x minus 2. So our question is, I don't like fractions, okay? I'm a math person, and I don't like fractions. So what we want to do is kill off all the fractions. So if I identify what would be my common denominator, okay, what would my common denominator be? I need an x minus 2, I need an x, I already got it. I need an x minus 2, I already got it. So my common denominator is x times x minus 2. If I multiply through by that, then it's going to end up reducing everything to where I don't have to work in fraction world. Okay? So it's easier for me to say, because remember that math people are lazy, it's easier for me to say, what would your common denominator be? But what I'm really asking you is, what's the least common multiple among all of your denominators? Okay? So what are we going to multiply by? I'm going to multiply all three chunks by x times x minus 2. So this is going to be times x minus 2. This is going to be x minus 2. This is going to be x minus 2. Oops, sorry. Okay? So now any number divided by itself is 1. So this has an x minus 2, and it goes away. That leaves me with x times 7x plus 1. Okay? This one, any number divided by itself is 1. So that leaves me with plus 4 times the x minus 2. And this one is awesome, because the x reduces and the x minus 2 reduces, which means all we've done is reduced everything but left it with a negative 8. All right, so holy cow, what's going on? I took it out of fraction world, And because I multiplied through every chunk, I didn't change what this equation is. I just changed what it looks like. So now, all of a sudden, this is a whole lot easier to manhandle. So what's something I know how to do? Well, I know how to distribute. So if you don't know what to do something you know how to do. I know how to distribute. So let's go down that path. I'm going to distribute this x. So I get 7x squared plus x plus 4x minus 8 is negative 8. Okay, so I distribute the x, I distribute the 4. And now I'm going to combine like terms, so I get 7x squared plus 5x's minus 8 is negative 8. I'm going to add negative 8. Sorry, I'm going to add 8 to both sides. So why am I doing that? Because I want that equal to 0. Okay, I want it equal to 0. And then I'm going to figure out what to do. So I've gotten into a whole bunch of terms, now get it equal to 0. So I'm going to add this 8 over. So that gives me a 7x squared plus 5x equals 0. Now decide how to handle it. This is quadratic. So let's try factoring. I can factor out an x. That leaves me with 7x plus 5 equals 0. And now you should be back in familiar territory. So I've got two factors that when I multiply together, I get 0. One of these must be 0. So I'm going to take the first factor and say you can be 0. I'm going to take the second factor and say you can be 0. And now I have run out of room. Okay? So I'm going to subtract 5. Sorry. And then I'm going to divide by 7. So I get a negative 5/7. So I have two answers. One is 0. One is negative 5/7. Now check. Come on back up here. I'm not allowed to use 0. So 0 is extraneous. It means I did all of my math right, but for some reason I can't use that answer. Okay? So for some reason I can't use the answer. I can't use 0. I generated a 0. Don't use it. Which means I only have one solution, and it is negative 5/7. Okay, do not use the 0. It's extraneous. Okay, so I'm going to finish up with some more examples in the next video.